Hi guys, welcome to day 4. We are going to use word problems and make functions out of them. So we're going to look at data, cyclic data, and make a sinusoidal model out of them. And then we're going to look at word problems and answer questions. Okay, first set of data. Now, first we have to check, is it cyclical? So we're years versus population. So as the years go up, check your data. It looks like our data is trending up, and then it looks like it's coming back down, and then it looks like it's going back up. So it looks like it's cyclical. So in order to start, first we need to determine what's the min versus what's the max. How high is this curve going and how low? So it looks like the height of the population is at year 4. It looks like it's at 13. And the min looks like at year 10, it drops down to 11. And then it looks like, see, it's cyclical. It goes back up. At year 16, we're back up to 13. So let's graph that. So we're going to graph, we'll just kind of eyeball it. Let's make that a little smaller. Year 4 is here at 13. And year 10 is down at 11. And we've got year 16, once again, back up to 13. Okay, so that's our start. So that means that our midline is going to be right in between the two of those. So in between 11 and 13 is 12. So I'm going to make my midline going through 12, and that's the first thing that I'm going to add into my function, which I'm just going to move down to the bottom of the slide. So I know at the very end, I'm going to have a plus 12 for my vertical shift. Okay, then I need to figure out my amplitude. Well, it's going the function's going 1 above and 1 below 13, which means its amplitude is 1. And from now on, we are always going to match cosine functions. I guess there might be a few exceptions, but for the most part, we're going to line up cosine functions instead of sine functions so that we all have the same thing. You could do both, but for ease of use purposes, we're going to do just cosine. Okay, next we need to figure out the period. So the period of this function looks like it starts at 4 and goes to 16. So 16 minus 4 means that the length of each cosine wave, so this length right here is 12, and then it repeats itself. Okay, so what does that mean in the function? Then I need to take 2 pi over that number b and set it equal to 12 to figure out what b is. So if I take that equation and try to solve for b, I get 2 pi over 12, which is pi over 6. So I'm going to write pi over 6 here, and we need one more set of parentheses to figure out our phase shift. The phase shift is the beginning. Where does this cosine curve start? Well, this cosine curve starts here at 4. So we're going to put t in, and then since it went right 4, we'll do t minus 4 for our phase shift. Phase shift starts at 4, so our function is going to be t minus 4. This is a representation of the second kind of word problem that you'd see. Not so much from data, but we don't need to find the equation because it's already given, but we're going to use the equation given to find some stuff, like part A. So it says find the min and the max of the sales. So this is sales in hundreds of cans of soft drink of soft drinks, and it's modeled by that. Okay, T is time in months, so we're going to find the minimum and the maximum sales. Okay, so the max is going to be the 13, your midline, plus the amplitude, which is 18.5, which is, and if that's in terms of hundreds, I think that'd be 1,850 cans. That would be the max. The min is going to be your midline minus the 5.5, which ends up being 7.5 or 750 cans. The min and the max. Find the value of T which sales first exceeded $1,500. Okay, well, part B, 1,500 would be the same as 15. So I'm going to set 15 equal to 13 plus 5.5 cosine pi t over 6 minus 3. Okay, so let's subtract the 13 and we get 2. And we'll divide by 5.5. 5.5 is 11 over 2. If I multiply by 11 over 2, I get 4 over 11. Cosine pi t over 6 minus 3. Now, I need to get rid of that cosine. I can't do anything in the parentheses without getting rid of the cosine. So I am going to do inverse cosine of 4 over 11. And that'll give me pi t over 6 minus 3. So on my calculator right next to us, inverse cos of 4 over 11 is 1.1986, so 1.199 equals pi t over 6. And if I add that 3 to both sides, I get 4.199 equals pi t over 6. If I multiply that by 6 and divide by pi, I end up with time equal to 8.019, which again, T represents a little over 8 months. Okay. The last question says, during which months do the weekly sales exceed 1,500 cans? Okay, so that means that I am going to use a graphing calculator for this. I'm looking to see where my function is above 1,500. So I went ahead and graphed this in Desmos and then took a picture of it. And I'm going to see if I can upload it right now. There's a picture of it. You can see that, you don't need the other notes. You can see that the two places where my graph is above the line y equals 15 is here. So I'm going to make an inequality, and I'm going to say that 3.44, so after almost 3.5 months, it's above 1,500, and then it stays there until 8.019, or a little over 8 months. When the so every cycle, that's how long it's going to stay above 1,500 cans. Okay, so your homework is to try on Google Meets if you have any questions for writing these functions. 1, 2, 3. I will be available for questions.